Okay, so for particles, what you do is exactly the same thing. It's QV cross B, okay? So the velocity is your index finger. The magnetic field is the second quantity, so therefore it's your middle finger. I'm sorry. Velocity is your index finger, magnetic field is your middle finger, and then the force is your thumb. Now, keep in mind that a negatively charged particle, there's a minus sign in front of that. It's QVB, right? So if Q is negative, it's opposite the direction of your thumb. Okay, so, some people use their left hand. I'm way too unclever for that, so I'm just going to use my right hand here. Okay, so index finger is this way. The velocity is that way, right? Magnetic field's into the page, and so the force is down the page, but it's negative down the page, so it's up the page. And these, by the way, these are the trickiest ones on the whole assessment. Okay, let's see. Velocity is down the page. Magnetic field is to the right on the page. Okay, and so my thumb is pointing out of the page, and since it's a positive charge, it really is out of the page, and that's what that answer is right there. Okay, the dreaded compass problems, right? Okay, so which way must a proton move to experience a northerly force in a vertically upward? Well, vertically upward we take to mean, if we're looking down on a map, vertically upward is out of the page. Vertically downward would be into that page, because we're looking at a map, and into the page of a map is into the ground, and out of the page of the map is into the sky, right? Okay, so let's see, it's a vertically upward magnetic field. So vertically upward is this way, right? It's a northerly force, right? And it's a proton. Remember, protons are positive, right? They're always very positive about things. Okay, and so the proton's got to move, the velocity has to be to the west. Okay, remember, it's never eat soggy wheat. It really is wheat, it's not waffles. People say it's waffles, but I don't think so. Okay, electron moving south. So the electron's moving south. Experiences a force to the west. Okay? Which way is the magnetic field? So it's moving south, force to the west. My middle finger is pointing out of the page, but it's an electron. Remember, electrons are negatively charged. And so it's negative out of the page. It's therefore into the page. Therefore, it's vertically downward. Okay? If you say X on these problems, I will not mark it wrong. I might say something sarcastic. I might call you a nilly. I just might. You take your chances. That's what you do. Okay, here we go. Okay, so let's see. Velocity is up the page. Magnetic field is out of the page. And so the force would be to the right, but it's a negative particle. So it's negative to the right is left, and that's the correct answer. All right, be careful. Beware the Ides of March. And negative particles. Okay. Walking around the camera, but not kicking the camera. Okay, index finger to the right. Magnetic field is out of the page, and the force is down the page, right? It's a positive charge, so the force would be really down the page. There's no minus sign to deal with. All right, here we go. I know I'm going to kick something over. All right, which way must a proton move to experience a vertically downward force in an easterly magnetic field? Oh my God, you poor kids. I really expect you to do this. Okay, so let's see, vertically downward, the force is definitely, my thumb is pointing into that map, right, because that's vertically downward. Okay, it's an easterly magnetic field. Oh, it's so okay, so my thumb is into the map because it's a vertically downward force. My magnetic field is pointing to the east there, and my thumb is pointing north. So it's a proton, and it really will go north because it's a positive charge. Protons are positive. All right, here we go. Electron moving east. Oh, man. I'm always walking around. Okay, electron moving east experiences a force to the north. Force to the north, moving east. My middle finger is into that page, right, which would be vertically downward, except it's an electron. Electrons are negatively charged, so therefore it would be vertically upward or out of the page. Yeah? All right. Let's try. Let's see if we can scroll. Scrolling's a challenge, you know. Especially when you get older. Okay, here we go. Okay. Especially when you zoom into like 5 million times. All right, here we go. Oh, negative charge. I think I can handle it. Okay. Velocity is this way. Magnetic field is this way. Force is out of the page, but it's negative, so it's negative out of the page, therefore it's into the page. Negative things go opposite the direction of what you do. Okay. All right, here we go. Up the page. Magnetic field is out of the page. I bet that was frightening. All right. And then the force would be to the right. Okay. It's a positive charge, so it really is right. Okay. Which way must a proton move to experience a southerly force? In a downward, vertically downward field. Okay, so the force is southerly. The vertically downward, I've got my middle finger pointed right at that screen. And in order to do that, the proton would have to go west. It is a proton, it is a positive charge, so therefore it really would go west. That's the correct answer. Okay, here we go. An electron moving south experiences a force vertically downward. B is what way? Okay, electron moving south. Electron's moving south. It's got a force that's vertically downward. Okay, so I'm putting my thumb into this page, because remember, vertically downward for a map problem is into the page, right? This is my velocity is south. The force is into the page, and so notice that the magnetic field is to the west, but electrons are negative charges, and so it would be negative west and therefore be east. Okay, those are the hardest ones. I hope that helps. These are the ones to practice, really.